Flip it over. Mr. Wade, challenge us. We want more challenging problems. We're honor students. All right, I'm glad you said that, actually. Turn it over. We've got some challenging sequences on that.
Okay.
All right. Next. What are the chances? The second day we film, the fire marshal comes in. What are the chances, right? But oh well, kids. All right. The show must go on. Okay. 7, 9, 11, 13. All right. So obviously what is happening to get from 7 to 9, 9 to 11, 11 to 13? Plus 2, plus 2, plus 2.
I'm serious.
A sub 1, A sub 2, A sub 3, A sub 4. Now, convergent or divergent? That is divergent. It's just going, it's just escalating, right? Okay. Once again, it's a, what type of function do you think? Linear. Okay, very good. All right. Now, the fifth term would be? 15. A sub 5 equals 15. All right. And the nth term, the nth term. Now we're getting, okay. Now we're getting more advanced. Now the plus 2 is all fine and dandy. Yes, you add 2 to get to the next step. But how do you get to the nth step?
You use the equation.
Okay. Well, here's where you have to work. Make a little table off to the side for yourselves. All right? Here's the best way to do it. Let's analyze the data here. The n will be the subnumber. Okay? So 1, 2, 3, 4 is the information we have here. We need to put it in the file. The a sub n is the outcome or the term. When I plug in 1 into my formula, it should give me 7. When I plug in 2, the outcome is 9, 11, 13. Now the plus 2 is part of the pattern, yes, but it won't get you the nth term. All right? Here's how to get the nth term. You have to think about it. Either you see it or you don't see it. Right? But if you look at it long enough, hopefully you'll see it. All right. Now, usually it's easier to do these patterns if you look down here in the lower regions instead of 1 and 2. Look at the 4, go as far as you can. How do I turn a 4 into a 13? Lots of ways, infinite ways. Think about addition or multiplication or a combination of both.
Multiply by 3 now. Times 3 plus 1.
Okay, let's see. If you triple it and add 1, that'll work. Let's see if it works here. Triple add 1.
No.
Not quite. Okay, you're getting close enough. Something else we could do to 4 to make it 13. Do you see it or you don't see it?
Double it, I forgot.
Wait, oh, okay. What if we doubled it, 8, and add 5, 13? That works.
Square it then.
What if we double this one? Double this one and add 1.
Yeah.
I mean, or add 5. And we're back from commercial. Okay, so if you multiply this one by 2 and add 5, does that make 11? It does. Oh, wait a minute. What if we double this one?
Yeah.
4 plus. Oh my goodness gracious, look at this. It's happening. It's actually working. Something's happening. All right?
What?
Double this, add 5, it works every time. So see, you have to find the right one that works. Therefore, the nth term would be double the n and add 5. How about that? So the pattern is 2n plus 5. Okay? You just have to look at it long enough until you think about it. Now, I'm not going to give you something wacky like multiply by 11 and take away 7.5. Okay? It's going to be obvious. Okay? We'll double it or triple it. Okay? And there you go. So in other words, hey kids, what's the 100th term in the sequence? Well, you can keep going plus 2, plus 2, plus 2, or
2 times
okay, 205. Plug it right in. There you go. Okay, good stuff. All right, so that's the nth term. All right, next one. 6, 9, 12, 15. Okay. I'll give you some strategies today, some strategies on how to do these. All right? And eventually we'll build up to the hardest sequence we're going to do in this chapter, which is the Wade theorem. All right? That's the hardest one. But I'm going to build you up in the meantime until you can do it. All right? So this one is, okay, obviously this one's going to be what? Divergent. No stopping this one. Okay? And the next term, what would be the next term? Yeah, what are we doing, just adding 3? Okay, so 18. But the plus 3, plus 3, plus 3, okay, how long do I add plus 3 to get a sub n? I don't know. So here's what we do. Okay, n and the a sub n term. First term is 6. Second term is 9. Third term, and fourth term. Okay, now remember, look down here at like 3 or 4. You can see it better down here than you can in the beginning, all right? Here's a little piece of advice. Didn't happen last time, but it does happen this time. These all have something in common. Okay, they're all multiples of 3. It's probably best, now these don't have a common multiple, but if you see a common multiple, I would go ahead and break it down because your brain can deal with it better if it's smaller numbers. So can we just say that this is 3 times 2? 3 times 3, 3 times, and 3 times. Ah, nice. So we know 3 is part of the final formula, 3 times. All your brain has to do is process these numbers. How do I make 4 turn into a 5, 3 turn into a 4, 2 turn into a 3?
Triple it.
Add
Okay.
plus 1, right?
So we're going to triple,
Add a factor.
And then plus 1.
and then this is going to be the number plus 1, exactly. Therefore, a sub n equals 3 times the quantity,
N plus 1.
and that number is n plus 1. Very nice, Steve. All right, well done. So it's 3 times n plus 1. You may also write that as 3n plus 3 if you want to distribute. It's actually better to leave it factored, but 3n plus 3 is also okay. How about that? Okay, and when you break it down, it's just easier for you to see that. Okay, next one. 4, 8, 16, 32. Okay. All right, definitely what? Divergent? Isn't this just doubling every time? So it's just escalating, right, exponentially? And so the fifth term would be what?
64.
64.
On that
Now,
last one, could we put 3n plus 3?
yeah, that's fine too, yeah, sure. All right, now, the nth term, when you do the nth term, let's see if we can find a pattern here. 1 gave me 4, 2 gave me 8, 3 gave me 16, 4 gave me 32. Okay? 2 ways to do this one, actually. You can do the common multiple again. So if you want to take out a 4 from each one, you can do it that way. Although these are really special numbers, so actually, you could do it without even taking out the 4. If you want to, you can. But you know what that number is right there? Actually, let's put it here. What's so special about 32? Is that, wait a minute, grains of rice on a chessboard? Isn't that 2 to the 5th?
Oh.
And isn't this 2 to the? Oh, there we go. Yeah, 2 to the 3rd, 2 to the 2nd. You can just do it by powers of 2 if you want. Or take out the 4 and do it that way. Same thing pretty much. Okay? It'll look different, but it's the same thing. So, every term is going to be 2 to the n plus 1, and we got it. Very good. All right. It's all about just looking at that problem long enough until it all comes together. It's like, oh, that works. And you know when it works because it generates every single one of them, doesn't it? Okay? All right, this will have lots of implications in computer programming if anybody does that. Okay? Trying to make formulas. You can put this on an Excel spreadsheet, actually. Put in your little formula, see if it works. See if it all the sequence terms.